to Gus Codes. I am Gus, and in this session of xganso I will research game system frameworks based on our requirements and implement them with the help of ChatGPT. To structure today's sessions, I defined the following goals. First, the research part. I will collect game system frameworks that meet our basic requirements: flexibility, extensibility, and modularity. As we gather more knowledge, we can define additional requirements. Second, the implementation part. For each potential alternative, I will implement the framework, a set of mechanics, and a basic example. For the mechanics, I selected a set that encompasses various aspects of the game: UI with the renderer, combat with movement and attack, and permanent changes with level progression as a result of the combat, and skill tree, which is non-related to the combat phase. Let's start exploring. First prompt will be about the game system frameworks based on our requirements. We might need to iterate over multiple interactions as we gather more knowledge and understand better the problem. Based on our question, I think that we got a more generic answer that we were hoping for. In this case, I think the ChatGPT thought more about the entire framework, like the engine per se, and not about the game mechanics. So we're gonna try to refine a little bit our question and try to get a more specific answer, because we're not really interested in some of the aspects at the moment. For instance, the game state manager, the system manager, this is which we're gonna focus. Entity component system is also an idea. So let's try to refine our question to see if we can get a better answer. ChatGPT already has some previous knowledge about xganso. He knows it's a turn-based tactical game. Sometimes ChatGPT writes the goal or what he understands from your question, and I think this is very good for us to understand if his reasoning is correct as well. You want a flexible way to define and manage game mechanics like unit moving, attacking, using abilities. That's exactly what we're aiming for. Each of these mechanics should be isolated in logic. That's one of the part. Easy to extend or swap out, able to interact with shared game state. I think that's absolutely perfect description of our problem and what we're trying to find out. Let's see what are the suggestions now. I think it's a valid system. I would prefer something more proved. So in this case, something that already exists. Maybe now is our time to start giving suggestions for ChatGPT. So let's try to rephrase the question a little bit and see what comes out of it. Okay, so now we are getting somewhere where we think it's more appropriate. So his idea is this component-based design inspired by this ECS entity component system. Let's see how it works. Okay, right now he's already giving a lot of coding, which is not really my goal now. Let's try to see if we can get other alternatives and a comparison between them. In this part, I took some of the ideas that he provided and I said that I liked them, so continue using them. And also I gave hints of other possibilities. We have a little bit of a bias answer because we added these new ideas of inheritance composition, and later we're gonna see if there are any more that ChatGPT can come up with alone. So the first one is this inheritance. It's simple, it's good for a small scale project, but the problem is that the class hierarchy becomes a mess and it's very difficult to mix them because you create this explosion of states. That's usually not a good idea. Usually people prefer composition over inheritance. The second one is this composition. Basically you have each unit having the components and then you just get the component. See here, remember that I like this one. I don't understand quite. Okay, add mechanic. Okay. And ECS, this is more data driven. Okay, we have a functional event driven also. Okay. Inheritance, so out. Composition is good. Component plus mechanics is good. I think they are very similar though. ECS is good, but it's a little bit more complex as I remember. And functional, I think functional is similar to ECS. He's proposing a CBD with mechanics, keeps the architecture simple and Pythonic. That's also very important to use something that benefits from the language that you're using. Let's try to ask if there are any other that he can think about. Okay, state-driven system. That could be for AI. Data-driven. Okay, that seems very similar to ECS. Tag-based logic. That's also similar. Rule engine decision graph architecture. Seems to be more like intelligence-oriented, maybe. There's a lot of architectures that we can use. The idea may be component-based design. Let's go for this composition and component-based, and also let's explore comparing to ECS, which I also like. I was asking about this difference between composition and CBD. The idea is that the composition is more of the object-oriented principle and not necessarily that you isolate all the logic in a separate component, but rather that you have these different parts. And the component-based design is basically this composition applied. You put all your data and your logic in this, for instance, movement component, and this movement component will solve everything. And then you just add this component to the unit and this unit can now move. And then, for instance, if now the unit should be able to fly, you just remove the movement component and put the flying component. And the ECS is similar, but the entity is purely data and you can do everything together. All this bulk processing is more like data oriented. I don't really like this. Let's try to make the ChatGPT understand our ideas. We already did some research previously, and previously the CBD was called component-based architecture, so I would like to use that terminology. And as far as I am aware of, it's very similar to how Unit deals with components. And ECS is part of this DOTS, this data-oriented of Unity, and is more focused on data-oriented processing, this technology stack. Now let's see the difference. The idea here is that each game object holds all the data and also the logic. I don't think that this interdependence is very problematic for component logic. You can always ignore if you don't need, or you can have shared data between them. And this ECS is more that you have this structure. Everything is directly in one, so you can do this bulk processing because of it. Everything is being compared to Unity, but I want a generic evaluation and not Unity-centric. This is the part that we can conclude our research. Let's hope that this is the final answer we're looking for. The component-based architecture, they have an entity that's an object instance, and then the component is the module that holds the data and the logic. That's very fine. The components are attached to the entities, and the behavior is distributed across the components. And then the mental model is that the character has a component, and each one is responsible for processing themselves. There can be a little bit of interference between the logic, but I think it should be okay if we can design very self-contained logic in each component. And the ECS components are pure data. Entities are just IDs. The idea is that it's kind of like a functional processing. The position and velocity, there's only data, and the entity is just an ID, and then you just map them. There's no object behind it. I don't think we are too much worried about too much performance at the moment. The data and the logic being coupled in the component is not much of a problem for us. We also need something to trigger everything, but inside each object it will be triggered by the components. Our turn-based statics, we can use the CBA or a hybrid, light ECS. Let's see a little bit more about that. I think it's kind of simpler, so CBA should be our starting point, and maybe going towards ECS if it scales, but maybe go to a hybrid. I need one more question about some difference and about this hybrid ECS, the light ECS. As my understanding, CBA is more related to object orientation paradigm and ECS more towards functional, because the CBA uses these objects to contain everything, and of course uses composition over inheritance because inheritance is such a big mess. And the ECS, I believe, is more functional in the base that, of course, there's a state in the end that's kept somewhere, but the data is not organized in an object per se. Exactly, it mutates the states. That's why it's not purely functional. Now let's see the light ECS. It's a blend. Entities are still classes. Okay, components may still have small behavior, but mostly data carriers. Oh, okay, so in this case, it would be, instead of putting the logic in the components, the logic would be in an external system. And then the movement system would call all the entities that, for instance, have a position or have a movement, and of course you have to do the checks. It's a little bit more of you're structuring the data more in an object-oriented idea, but then you're structuring the logic, the processing more in a data-centric approach. And it's a step between both. I think that we can start with the CBA. If we think that's becoming too much of a mess, we can kind of move to a hybrid, so we extract the logic to an external system, and then we can move towards ECS. I think I'm very happy with what we achieved here. We managed to learn more about, first, what is exactly our problem. So in the beginning we asked a question and the answer was very generic and touched a lot of different aspects. And then we managed to define the scope better and better, and also understand what's the terminology that's already in use in such area, and try to understand all these concepts and how they relate to each other. Now we have a very good plan We go CBA, that's the component-based architecture, that's the simplest one to structure. And then if we feel that it's not fulfilling our requirements anymore, maybe about performance, maybe about structure, we can shift towards this ECS, which provides a very powerful modularity, flexibility, and performance. And we have a very specific step with this hybrid ECS. I think for the prototype, we can try to go for the both extremes. Try to do one CBA approach and one ECS and see what are the pain points, what are the benefits of each alternative. Now that we found ideas for our game systems, let's implement a simple prototype for each of them, the CBA first and then the ECS. Our goal for the implementation is to do a quick functioning module with the least effort. We'll use ChatGPT to help and we won't be concerned if the code gets too messy. We're gonna try this implementation, but of course we might have to adjust some points. First of all, I'm gonna change the name from entity to object, and I'm not gonna do back reference. I want all the components to have the same structure and not have different ones. We're gonna have to adjust that later. Before we start implementing a lot of stuff, let's try to make ChatGPT understand what our idea is. Okay, we're gonna start with the renderer. It needs the sprite and screen, and also it needs position, which is defined in the movement. Let's define the component protocol. I'm not gonna have the delta time at the moment. This starts the first problem. I don't want it to have a back reference, and I want the update to be also as the renderer. Let's try to see if we can... Okay, let's do different. Let's, for the time being, say that the position is here. Let's try to run. Okay. Okay, I have one question about the renderer. Now we have our first component. Now let's create maybe the second component. I don't like the velocity, I don't want it. Okay, I like this. Okay, as said, the update can be this rendering idea, so the animation over time, but for the time being it's gonna be only discrete movements. And then let's see how it feels here. Currently it's not moving because our renderer is not receiving this information. So now we have to find a way for the modules to communicate without having dependency. Okay, let's use the back reference after all. Now we have the problem that I don't really want to know where this comes from. It's becoming very complicated. Let's just use this simple one. Okay, now it's working. Perfect. Okay, we're gonna rename to combat. Let's see this idea of damageable. Ah, interesting. We can create this damageable that says what are the methods, and then we can see what are the targets. That's interesting. Maybe it's just a combat per se at the moment. Of course. In the future we'll do some checks, but in the time being it's fine. Forgot to print here. Of course. Okay, let's move on. Okay, seems to be working, the X-beam. And lastly, let's do the skill tree. Let's not have prerequisites, let's just have required level. Okay. In the future we can do these triggers and events and stuff happening. I think that as a basis this work, we can always extract the data somewhere else, but I think overall it seems good. For instance, the position could be like in the unity could be the transform, and then the movement operates on it. So maybe that's the idea of the hybrid. You just have the data and then you operate on those. Maybe something to evaluate. Let's try the ECS now. Perfect, I agree. We have the components and then we process all the components and see which entities are concerned there. Okay, still interested to see how it's gonna work. I think it's getting very complex here. I would like to keep it a little bit simpler. So I think I'm gonna do some refactoring, but first I have to understand what is it doing. Okay, maybe let's start with the ECS here and we'll ask some questions. Okay, the entity is an integer, that's fine. The component is just data. Okay, so it's just data. So this component is actually the data and the system is which executes. Okay, I understand now. It's already the component time. Okay. Let's go back. Okay, so these are our components, And now we have to define these systems. Okay. Let's put the screen as well here. Okay, now I got this concept. Okay, let's make the movement system. I have to set like the source we'll call, or entity, right? Okay, we kind of sped run a little bit because it's very similar to what we had in the previous. It's just this division and a little bit with this get component ideas. And now let's try to run it with Python. now we have similar implementation in both. Surprisingly enough, the ECS, I felt it's very pleasant to program and to structure. I thought that the CBA is a little bit messy, in particular with this idea of the back reference, because here in the ECS, the data is stored in this word, as we call, and you can access all the data that's in there. And in the CBA, the data is fragmented and it's a little bit tougher to find. And of course here we are always checking if the data exists. If it doesn't exist, the component, then we just ignore. So I think moving on, I might move towards a hybrid between CBA and ECS. I enjoy this separation of the ECS. I thought it would be too complicated, but once the framework is in order, it's get very simple and very easy to program. And the CBA, it's a little bit messy with all these components. I don't know, it's not very pleasant overall, some parts of it. And also the ChatGPT was very helpful in our prototype, provided very good examples, and of course we had to add some stuff. And some stuff that you want to change and it's not super relevant, it's better not to give a feedback for ChatGPT because it only consumes time and sometimes you get it wrong anyway. So you have to understand what you're doing, and overall very good help and guidance. And comparing just the size, it would be 214 and roughly the same size for both. I mean, there are some simplifications here, I think, in the ECS that I could have here, but for instance these updates are not necessary. So in the end, a little bit smaller, the CBA, but I think the overall structure of the ECS is much better. To summarize, today we researched game system frameworks and implemented prototypes for them. With this step, we gain more knowledge about what we want, and actually we gain a lot of knowledge about how things work in practice. We had set the following session goals, which we fulfilled. First, we researched and selected the game system frameworks that meet our requirements. Namely, we explored the CBA, the content-based architecture, and the ECS, the entity component system. Also, there is an alternative of a hybrid between the both of them that we didn't explore in practice, but it's an idea for the future as well. Afterward, we implemented a simple prototype for each of them with the basic framework, a set of mechanics, and a simple example. Surprisingly enough, the ECS was much simpler than expected, and it provided much better data and logic structuration. Moving forwards, I believe we're going to focus on the framework ECS, but keep in mind that we also can switch to CBA or a hybrid if we want. I just like the idea so much, and the implementation is very simple, and at least our framework made it possible to be very simple and very clean. It surprised me. I would have picked the CBA before the implementation, but I believe that now that we already have established the framework for the ECS, the structure and the separation of the word data all in one place, so simple to access, it just brings so much benefits. In the next sessions, we will incorporate the ECS to our xganso and start developing some of the systems, which we already have a base, but maybe we have something more complex, and how to structure all the data with the entire game and the entire world and the combat and so forth. So we have to do a little bit of thinking there, but we already have a solid base. Thank you for your time, and see you in the next session.